Miller sweep is basically a time-based generator circuit, and it has two transistors Q1 and Q2. You can see on the screen. Q1 actually acts as a switch, and Q2, here you can see the Q2 is connected in a common emitter configuration, a common emitter amplifier configuration, which has a very high gain. Okay, so I'll just explain the working of this figure, this diagram, and you have to draw its output on only. The aim of this experiment is to draw the form of this circuit. All right. And since now up till now you are very much familiar to circuits and all and how to implement them in multi-sim, so I think it's very easy for you to implement. Okay, so in this circuit Q1 and Q2 both are same kind of transistors, and Q2 acts as a switch. Okay, and Q2 is a common emitter amplifier. Initially we are giving a pulse at this Q1. Okay, and it can be a square input. All right, so initially we assume that Q1 is in on state and Q2 is in off state. So at this point of time, the voltage across the capacitor, okay, the capacitor CS, the voltage across it will be VDD or V1, which we have applied at the top, 10 volts. Okay, and the output, since Q2 is off, so what will be the output? That will also be equals to V1, right? Since Q2 is off, so there will be there will be no place for the current to flow and reach the ground. Okay, so the output voltage V0, that will also be equals to V1. Okay, now what happens? Now let us apply some pulse, or let's apply some negative polarity at the input of Q1. Okay, so what will happen? This Q1 will go off. Okay, then if Q1 goes off, then Q2 will try to turn on. Okay, so the emitter based junction of Q1 is reverse biased when we apply some negative pulse at the input of Q1. Okay, so it turns off. Now what happens to Q2? It tries to turn on. So as the transistor Q2 starts conducting, what will happen? The output voltage will start to decrease. All right, and this decrease in the output voltage, that will depend on the capacitor CS. Okay, because this CS is coupled to the base of this transistor Q2. Correct? So now the rate of decrease of the output, that will depend on the what? The rate of discharging of this capacitor CS. All right. So that means our output will now be dependent on the time constant of the discharge of this CS into RB. RB is this input resistance, which you can see at the input of Q1. All right. So that is the time constant of the discharge of capacitor. So now as the value of time constant is very high, then this discharge current remains constant. Okay. So now what will happen? The result will decrease linearly. Okay. So basically what we are doing, we are generating a linear output by giving a square input. All right. So I think output is also given. Yes. So you can see the output is linearly decreasing. Correct? Can you see the lower figure? In the bottom figure you can see V out is given with respect to time. So with respect to time, V naught is decreasing linearly. All right. So this kind of waveform we will get. Is it visible on my screen? The red one is the input, the square pulse we have given at the base of Q1, and at the output we are getting a combination of linear variation plus the pulse. All right. This kind of waveform you have to trace at the output of this circuit. Okay. And then comes the experiment number 11, which is a bootstrap sweep circuit. This is also a same time-based constant generator, but there is one diode which is we have introduced. Okay, so this working of this circuit is very slightly different. Okay, but this is also a similar kind of figure, that is also a time based generator circuit, but it actually uses a feedback kind of thing in it. Okay, so that this experiment is not necessary to do today you will only be performing experiment number 10. All right, so if you have any doubt in this circuit, you may ask. And those who have already completed experiment number 10, they can go for experiment number 11. All right. Any doubt? Any doubt, students?
Basically, we have to do today 10th one, right, ma'am? If we have not done 10th, because we have shown till 9th, right? Hello?
Ankush, you are not audible. Are you saying something?
Am I not audible? Hello? Hello, hello?
Yes, yes, Ankush.
Am I audible, ma'am?
Yes, yes.
Actually, I was telling we have to show today 10th one now. If we
Yes,
have
yes,
shown till
only
9th.
10th. Only 10th. If you have shown up till 9th experiment, then you can show me up till only 10th experiment.
Okay, okay. Thank you.
Anything else?
No, ma'am, no.
Anybody? All right, so please start performing experiment number 10, and those who are present in the campus, they may reach at 10:30, they may reach lab, analog lab. Okay. All right, any doubt?